Alright, good morning everyone. Hope you all are having a good day. So we will be in chapter 15 today, talking about building and testing an environment. We'll be talking about performing vulnerability assessment. We'll be talking about testing your software, talking about implementing security management protections as well. Alright, so first thing we're going to discuss today is security testing. And there's really three major types of security testing we may use. Okay, so the first will be automated scanning. Okay, as the name automated implies, means that we pretty much just configure the test to run. All right, so some examples of automated scanning could include stuff like basically anything running on an IDS. Okay, pretty much anything running on, to an extent, you could argue a firewall. All right. Maybe even some enterprise malware solutions to support automated scans. Lots of different types of automated scans we may see. But the idea is that once it's configured, we don't touch it. Okay, that contrasts pretty heavily with manual attempts. All right, so as the name manual implies, means that it's going to be done exclusively through, manual intervention. So let's say that you had a particular switch, and you wanted to scan it and see which ports were open. All right, and you manually do that. That's a manual attempt. Okay, and then the one that's kind of in between, of course, can be tool-assisted pen test. Okay, so in a tool-assisted test, what you're using is using tools that aren't completely automated, yet they automate many tasks. So just think about those three things. All right. So what you always want to consider whenever you're doing any sort of security testing is you want to first think about what your goals are. And the goal of most information security is going to be the CIA triad. All right. So that should be a review. Okay. So you start off with the C, which is what? Confidentiality. Okay, making sure the data is confidential. Okay, then you move to the I. What's the I? Integrity. Make sure the data is not altered. Okay, then you have the A. What's the A? Availability. Exactly. So you always start off thinking about the CIA triad. All right, and you consider what does that mean for organization. Okay, so another way of thinking about this is saying that you're taking your organization and you're seeing, is what we have confidential? Are our systems accurate or inaccurate? Okay, these are the types of things you want to think of. Now, beyond that, okay, you want to think about the criticality of the system. Okay, if a system's critical, it means that it's central to the operations of the company. All right, if we're a for-profit company, what does that mean? Okay, it generates revenue, exactly right. All right, for a nonprofit company, what's that mean? Well, I should say nonprofit organization probably, but what defines the criticality of that? Okay, so have you guys taken a management class? So what's a nonprofit organization? Okay, well, they do have income, but they don't have profit, right? Okay, because they basically don't take a profit. So what's important to them? Okay, what about their mission statement? So what's your favorite nonprofit? What was that? Okay, Humane Society. So if they have a system that tracks dogs, okay, why does that matter? Why do we need to know what which dogs we have? Exactly. So, the nonprofit, we need to know which dogs have which vaccines. I'm not sure what happened with that screen there. Okay. What else do we need to know? We need to know who the dogs are. We need to know basic medical history about the dogs. All right. All that stuff is very important, right? Okay. So just think about the criticality of systems. Okay. Think about the sensitivity of information. All right. So say that we have very sensitive information, and if we had sensitive information, we'd want it to be confidential, would we not? All right, so that should be pretty straightforward. Okay, think about the likelihood of failure. All right, if you have a system that is older, let's say that it doesn't have redundant power, doesn't have redundant network feeding into it, is that a higher or lower likelihood of failure? Ceteris paribus is going to be higher. Okay, total risk. Think about every possible risk. Is that a fun thing to do? Okay, probably not. Impact on business operations. This should probably be number one. All right, because is anything we do more important than business operations? No, it's not. All right, so definitely consider impact on business operations. All right, so that's sort of thinking about it on the whole. So when you're talking about security testing, all right, but for security assessments, it's comprehensive. Okay, so when we have an organization, we have many different aspects we're worried about. All right, what's the outermost aspect? Another way to think about it is a layer. What's the outermost layer that a security professional would be worried about? Okay, the physical. Okay, so we want to make sure we have a secure physical layer. Okay, but when we're doing security assessment, we're assessing every layer. All right, so what else are we worried about? Okay, network. So we said physical, network. What are the other layers? All right, this should be a review, right? So what are the other layers? Okay, so we have systems / servers, right? Okay, what else? Two more. Okay, so I'm going to say endpoints, all right? And then we have applications, okay, and systems. So basically, every single one of those things is going to be included inside of a security assessment. All right? You can do this internally. If you do it internally, guess who's going to do it? Security team, right? Okay? Or you could hire external auditors. All right? Pros and cons to each approach. All right, certainly, I think that in most cases, it probably makes sense to use both internal and external. It's my opinion. However, let's say you're a nonprofit with limited funding. All right? Are you going to be hiring external reviewers? Probably not. Okay? Because does that relate to your mission? All right, if you're the Humane Society, is your mission to secure doggy information, or is it to provide dogs with a temporary home? Okay? So, yeah, I mean, you definitely want to keep that in mind. What is your mission? All right? And let's face it. Okay, let's say that we have a data breach of dog information. Do we even have to notify anyone for that? No. All right? Now, that's not to say there's not volunteer information, other information that may be sensitive. Certainly there would be. But you want to be practical. All right? Don't go thinking that the whole world is information security. It's not. Okay? So you have security audits. So I like to tell the joke here. This is why you would get an accounting dual major. You can go work for one of the big four. All right, working for the Big Four doesn't sound particularly fun to me, but I'm not you. Okay, so maybe you do want to work for the Big Four. Basically, this would be completely external. And so whenever you're auditing something, and generally speaking, this is looking for compliance with regulations. All right, so if you remember your favorite regulation, you'd audit for that specific thing. All right, you could have a larger scale audit as well, and you could also, of course, audit for things like system integrity. Okay, you guys have seen Office Space, right? What happens in Office Space? What's the big plot point? Exactly. So that would be something they would catch inside of an audit, right? All right. And that's why it's important. All right. So shifting gears a little bit, talking about vulnerability assessments. It's a bunch of definitions I'm going to throw at you. Okay. So you have the common vulnerabilities and exposures. Okay. And what this does, this is referred to as CVE. All right. It's a standardized way to describe a vulnerability and its impact. All right. You score it with the common vulnerability scoring system. Okay, so if something is, say, 3 out of 10, it's not very severe, is it? What if it's 8 out of 10? That's going to be pretty severe. Okay, so it's looking at the severity of vulnerabilities. And there's a lot of things that go into the CVSS score, or I guess just CVSS, okay? So certainly you'd want to consider what the impact will be if something happened. I mean, you have a vulnerability that you have to be physically in front of a system to exploit, that's going to be pretty low, right? Because generally speaking, attacks don't happen when you have physical access to a system. Because let's face it, people with physical access to the system likely have access in other ways anyway, do they not? So if I'm standing right here, I can access this computer. Yes, I can physically plug something into it. But guess what else I could do? I can just type and access the keyboard in a normal fashion. Sorry about that. All right, then you have common configuration enumeration, and this is basically a standardized way to describe and document system configuration issues. So, let's face it, if you buy a new switch, okay, and you plug it in to your network, and you have different systems across it, right, by default, that switch is going to allow a lot of stuff through it, right? Okay, probably going to allow everything through it. That's a configuration issue if that's not how you want it. Is that fair to say? Okay, so let's say that you meant to have certain ports be tied to certain VLANs. Okay, could we discuss that? Absolutely. Okay, that's certainly a possibility. So basically, it's just for configuration issues. All right, common platform enumeration. It's all about describing operating systems and software. Okay, so basically, a lot of where this comes in is to make writing policies easier. Okay, so you have various security policies that you're writing. Okay, you don't want to have to define every single term. All right, that's not a fun thing to do, is it? Because think about how many terms you may have inside of a security policy. Is it fair to say you'd have upwards of 100 terms? You probably will. Okay, so if you're using common language, you don't have to define everything. That's the whole point of this. All right, extensible configuration checklist description format. It's just a standardized way of writing a security checklist. That's all it is. Okay, open vulnerability and assessment language. This is a standardized way to describe any sort of security test that you may be doing, and also any procedures that you may have. Okay? So some different vulnerability scans. All right, so first let's talk about what a vulnerability is. Okay, so vulnerability is basically saying something that could happen. All right, so if I had an unpatched Windows, let's say 98 second edition, it's not going to have any vulnerabilities in it. Okay, it's going to have a ton, even if it were fully patched. Still going to have a ton of vulnerabilities, is it not? So right off the top of my head, I can think of one. All right, starts with an S. It's a protocol. It's not SSL. 3 letters, though. What is it? Okay, I'll give you a hint. This is the same protocol that was used for WannaCry. It's a file sharing protocol. Give you another hint. On Linux, the protocol is called Samba. SMB, exactly. Okay, that'd be an example of vulnerability. Something that can easily be exploited. It's unpatched. Okay, so you can use network discovery scanning. Okay, and as the name network discovery scanning would imply, what you're doing, you're scanning the network and you're seeing which ports are basically available to be accessed. Okay, so if a port is completely open, and that means that traffic can be passed to it in general. Okay, now there's a lot of other ways that we could have an open port yet still control the traffic. All right, and that's all going to be done through which appliance? Well, I guess there's 2 options here. What's one of them? There's not that many network devices. Which ones can control packets? Firewall is one. What's the other? Router. Those are the 2 that we have that can be very beneficial. But basically what we're doing, we're scanning the network, seeing what's on it. Okay, the network vulnerability scanning, so we get a little bit more in depth. So we've scanned a port, we see it has something on it, then we see what we can actually do to that specific port. Okay, so we're going to run through various tests. This is probably going to be fairly automated, if not tool assisted, but probably this is going to be automated. All right, so that's what we're doing there. Okay, web vulnerability scanning. Okay, you guys remember Corey's example, right? What did Corey do? Okay, so he was doing a web vulnerability scan. So he had a URL. I think it was actually a local address, but either way, same thing. So he had a local address, and he did vulnerability scan. He saw that it was able to be, that it was vulnerable to certain cross-site scripting attacks. And then what did he do? Did he not exploit that vulnerability? He did. Okay? Database vulnerability scanning. You know, I kind of realized we didn't actually have a database security chapter in the textbook. I should probably fix that, all right? But we're going to talk about database security in 402, all right? So basically what you're doing database vulnerability scanning is taking your database and you're seeing what it's vulnerable to. Is it vulnerable to SQL injection? All right, is it vulnerable to, there's a lot of different vulnerabilities. SQL injection is probably the main one we're concerned with. So basically that would be where you're inputting something. Okay. And basically, you know, you would input semicolon. What's a semicolon do in SQL? Okay, so it ends the statement, exactly. So then you keep typing, you could say something like drop table, whoops, that's an E, person. And what's that going to do? It's going to remove the person table, exactly right. All right. Or you could do something like okay, what's that do? It's going to return the entire person table contents. Why might that be an issue? Okay, so what's probably inside of a person table? Social security number. All right, so do you want some random person to be able to get your entire organization's social security numbers? So an easy way to avoid this type of thing is to block out certain words. So you could also do characters. So for instance, if you cannot run, or if you cannot, if you can't input a semicolon, does this work? Why not? Because basically what you'd be saying is you'd be saying insert into whatever table, and then you have the column, and then you say values. Well, you can't just put either of these functions in there. That wouldn't work. Okay, so that's why you have to have the semicolon. All right. So if you disallow the semicolon, you get rid of a lot of this, do you not? And that's why most of the time whenever you're inputting something into a database, it disallows semicolon for that reason. All right, but you could also, of course, disallow SQL words like drop, select, insert, those sort of things. So a lot of different things you could do there. Any questions so far? Okay, penetration testing. All right, so penetration testing is basically just where you're trying to figure out a way into an organization. All right, and this can happen at any of the layers. Okay, so you can certainly try to physically access a company. All right, so if you have a traditional company, okay, it has a building. Okay, the building has a door. All right, what happens if you get into the door? You're in the building, okay? So then you have a server room back here. You get into this door, you're in the server room. That's penetration testing. Okay, you have a network, all right? And you figure out a way onto the network. That's penetration testing. So it has 4 major steps. Okay, the first is planning. All right, so planning is a very important step because it's where you get something that keeps you out of jail. What is it? Okay, so formal documentation. Okay, it's a legal binding. All right, so you want to make sure that it's written very well. All right, what happens if you don't get permission? Certainly can. Okay, so get permission, have an airtight agreement, have it signed. Don't leave yourself in any possibility of getting locked up. And by the way, you give yourself permission for everything. All right? It's like hypothetically, if any of you ever asked me for a letter of recommendation for grad school or be a reference or something like that, all right, I'm going to have you sign a FERPA release. It's going to give me permission to say anything I want. All right? Why do I do that? I'm not going to get in trouble. All right? Well, I mean, honesty is part of it, but I mean, bottom line is I'm not going to agree to be someone's reference I wouldn't say something positive about. All right, so the real reason is I don't want to get sued. I don't want Fort Lewis to get sued. So if you've signed over, you basically signed away your rights to where I can say anything. Now, if I don't have that agreement, can I say anything about you? I can't even say if you were in my class. Legally. I mean, obviously physically I can say. But legally speaking, FERPA prevents me or any instructor or faculty from saying anything about anyone. All right? So like I said, I can't even say if I know you or not. That's from a pure legal standpoint. Now, how closely that's followed, I'll put it this way. Look up and see any case that's been successfully litigated from FERPA. To my knowledge, there's not a single case. I think it's been brought up in about 4 cases. I believe they were all at the K-12 level. So make of that what you will, but I'm still not going to take that chance. What if I'm the first person to get sued? Do you think I want to lose money? It's me. Of course I don't want to lose money. All right? Information gathering and discovery. Okay, this is where you're going to study the organization. Okay, you're going to, if you're doing a physical, you're going to basically monitor it, see how people access the building. Some different stuff you could do. All right, can you use a thermal camera? What information may you get from a thermal camera? Where the server room is a big one, all right, because that's going to have a ton of heat. And that heat's going to be going somewhere. All right, I don't know where. Depends on how the server room is configured. Sometimes they exhaust the heat. Sometimes they have open air racks and they just have really powerful air conditioners. But either way, with an air conditioner, all right, let's face it, how does it work? Well, I mean, it's going to use electricity, yes, but in a more physical sense, how does it work? Well, it doesn't really move air from outside in most cases. I mean, there are commercial units that will bring in outside air, but for the most part, does it not work from exchanging heat from one location to another? Okay. So you've got the condenser, all right, and you got the evaporator. All right, and they exchange heat. Same thing with a heat pump. It just operates in reverse, does it not? Okay. That's exactly how it works. All right, now I'm not an air conditioner technician or anything, but at the basic level, you're exchanging heat from one location to another. All right. Attack. That's where you actually try to exploit anything you may have found. So for instance, let's go back to the physical example. So if you see that people swipe a card and that they then input a code, okay, and let's say you sat there with binoculars in your car and you watched someone's code. Are you halfway in? Now what's the second thing you got to do? You got to figure out some way to get their badge. Can you duplicate it? Depending on the technology, pretty easily. You probably, if you're doing physical penetration tests, you would obviously have the technology to duplicate a badge. All right. Now, what do you have to do? You have to figure out a way to stand within a couple feet of them without being a weirdo. All right, and that's not an easy thing. But you got their code, duplicate their badge. Are you in? Yeah, you would be. Okay, and then, of course, you report back your findings. So if you're able to get in, then guess what? You'd report that. Let's say you can't get in. Okay. Then what do? You'd report that as well. All right, whatever you find, you report. Now, let's say you get hired to do this. Okay. And they have a roof. And it's a one-story building. Could you cut through the roof? You think they'd be too happy if you cut through their roof, though? I can't imagine. All right. So, you certainly could, but they probably don't want you to do that. Why not? You could certainly cause hundreds of thousands, if not millions of dollars worth of damage. Commercial roofs aren't cheap, Why else? So if you're doing it during the middle of the day, that'd be pretty crazy. But even if you're doing it at night, could you accidentally cut a power line? Sure. Could you damage stuff inside? Absolutely. All right. So kind of shift gears a little bit, talk about code review. So let's say your organization has some internal coding. Maybe it's used for an internal system, maybe it's used for like their website. Either way, most organizations have at least some amount of code, So here is how you would go about the review process internally. You'd plan for it. You'd figure out what code needs to be reviewed. You'd figure out how you're going to do it, who's going to be responsible for what. Of course, you get permission. And then you do an overview. There's going to be an overview of what you're going to do. Prepare to do it. All right. Then you inspect the code. All right. This inspection process is going to be the biggest part by far. Okay, because what you're doing is, in a way, you're almost inspecting every line. No. Does that mean you're inspecting every line manually? Of course not. All right, let's face it. Is it possible that an application has millions of lines of code? Yeah, it's very possible. Who in their right mind is going to read a million lines of code? Anyone? Well, like I say, if someone were to do that, they wouldn't be in their right mind, would they? So what do we do instead? Okay, validate the process, exactly. So this is where you would go to key parts of the code. Let's say that we have a data processing section. Is it fair to say we're going to test to ensure that's done correctly? Yeah. You'd go to your loops. You'd ensure that there's not a single input that would cause an infinite loop. All right? Or, let's say that an infinite loop were triggered. You'd have an escape from that, right? Now, you guys have taken programming. I know that for a fact. I've looked at the curriculum. What else is important? So we talked about loops, talked about processing. What about inputs? Do those matter? Okay, they do. So you'd validate that the input process didn't have any problems either. All right, let's say that we're inputting something and we're inputting something that shouldn't be allowed. So I think that most programming languages, they also use a semicolon to end a statement, right? At least a lot of them do. All right. You should disallow characters like that. You should validate the input wherever possible. All right. And then what's the other major thing in any application? We talked about input. Output, exactly right. Make sure the output's correct. And that's basically what you're going to look at. All right. There's certainly a ton of tools. You can throw any possible output at it, just like when you're cracking a password. You can throw any combination of letters at a password, right? You can do the exact same thing with code review. All right, you find issues. Okay, is it fair to say that in a million lines of code, there's going to be at least an issue? All right, I think that's pretty fair to say. Okay, especially if the code's been around for a while. Because let's face it, you find an issue, you resolve the issue, and then what happens? You probably broke 5 other things, at least. All right. So you'd go back up to inspection, would you not? And you'd keep doing these 2 phases right here. Okay, and then once you're finished, you do a follow-up. It's basically like a post-mortem. Okay, where you discuss your findings, you discuss what you did to resolve it. Along the way, what's vital? Starts with a D. Documentation. Exactly right. All right, so what does documentation look like in programming? Starts with a C. Commenting. All right, you want to make sure you're following your organization's guidelines for comments. Okay? Because let's face it, most languages, when you comment throughout your code, can you not automatically generate documentation? Okay, you can pretty easily. All right, so that's code review. You have 3 major types. You got your static testing. It's basically where you have access to the source code, and because of that, this is mostly going to be an internal review. Okay, it doesn't have to be, but it probably is. Okay, dynamic testing, in contrast, is basically testing it in real time. All right, so you're testing it running, and you're seeing does it perform as expected with every possible input. All right, and then fuzz testing is where you focus on invalid inputs. So just as an example, if I had code that were supposed to tell me how much a transaction costs. All right, and I input -$20. What's the problem with that? Why can a transaction not cost -$20? Okay, well, it can be a negative value, but in that particular case, a transaction cannot cost a negative amount. All right, you can gain value from doing a transaction, but the transaction itself is going to always have cost greater than 0. All right, that makes sense? All right, test coverage analysis. All right, so basically what you're doing here is you're forming a ratio to see how much you actually tested. So what you do is you take how many cases you tested divided by the total number of possible cases. All right, and ideally, if you're using automated testing, what should this eventually get to? So it's a ratio, it's between 0 and 1, right? What should we eventually see? 1. Why? Exactly. That's the whole goal of automated testing. Now, that's not going to be a quick thing, is it? Definitely will not be. All right, so you want to consider the branch coverage. All right, looking at basically intersections. You know, how does it interface with other things? Testing conditions. All right, how does it handle conditional checks? So, for instance, if I had a condition, you know, let's say I greater than 0. You test stuff like that, that's a condition. Look at the different functions within the code. All right, it's probably going to have a bunch of functions, right? So you review all the functions. Look at the loops. We talked about reviewing loops. All right, statements. Okay, these are all things you would consider. All right, so security management processes. So this is where you're basically going to form the information security plan. All right, and the information security plan is something I assigned in here, is it not? How's that going? Okay, hopefully pretty well. So things to think about. How do you review logs? When do you review logs? You know, what are you looking for in log reviews? All right, that's an important thing to consider. Because let's face it, you know, you're not going to be able to review each and every log entry. You know, think about what Corey was talking about. They get millions a day from each server, and you're going to have hundreds of servers if you're at a sizable company, maybe thousands even. You're not going to be able to review those manually. So you're going to look for exceptions. Account management. We've talked about account management quite a bit. When do you create an account? What privileges do you give it? What rights do you give it? How do you handle when someone leaves? Okay, disaster recovery and business continuity. Chapter 2 or 3. How do you plan for disaster? Training and awareness. How do you make sure that your employees are competent? All right, a lot of this is going to be in which process before they're brought into your company. Starts with an H. Hiring process, exactly. So, you know, like I get emails about watching that anime stuff, and you know, I'm not a big fan of. Well, let me rephrase that. Well, let me just not comment on it, okay? But yeah, I mean, I get those about once a week, you know, and I probably do them maybe once a month. All right. For legal reasons, that's a joke. But anyway, you know, that's training and awareness. Okay? So you have key performance and risk indicators. All right? Hopefully you all know about key performance indicators, and hopefully you also talked a little bit about risk. Okay, I know we've talked about risk in here, actually. So the information security plan is going to encompass everything like that. Okay? It's going to encompass every layer. How do we manage it? Okay? And again, it's very complicated. All right, so I don't expect you all to give me a 50-page document. Okay? But you could probably put together 5, 10, 15 pages about this pretty easily. Is that fair to say? Because there's a lot of stuff here. All right. So for the next 15 minutes, take 2 minutes. Think about whether you think business should err on the side of security, whether they should err on the side of ease of access. All right, so take 2 minutes, think about that. Again, there's no right or wrong answer.